so the next thing we're going to add to our proofs justifications section of our notebook is the definition of perpendicular lines. So perpendicular lines intersect and form right angles. So if I had something like this, and so this is point A, and this is point B, and this is point C, and this is point D. So if I told you that line AD is perpendicular to line CB, so that upside down T, that is the symbol that you can use for perpendicular. So when you're writing out your proof, instead of writing the whole word perpendicular, you are allowed to use the perpendicular symbol. So go for it if that's easier for you. So if I told you that line AD and line CB are perpendicular, what that means is that angle ACB is a right angle, and that's what you would say. You would say angle ACB is a right angle. Mercy. I'm gonna just type that. It looks so ugly. ACB is a right angle. Angle ACB. That's what we could say by the definition of perpendicular line. So if those two lines are perpendicular, then they create a right angle. So a huge no-no is you don't want to say, oh, then the measure of angle ACB is 90. You can't jump straight to that. First, you have to say it's a right angle, definition of perpendicular lines. Then the next step, you can say the measure of angle ACB equals 90, definition of a right angle. So this is what you can say by the definition of perpendicular lines. You can say that it's a right angle. Then after that, then you can say that its measure is 90. So here is a proof. So I am just going to cheat a little bit, and I'm going to snip the given. So sneaky, Miss Briscoe. So here's your given. Change my font. Okay. First step is the given. So I know in the given that line AC and line EG are going to be perpendicular. And then it also talks about angle 5 and angle 6 in the given. So again, we are giving you things in the given for a purpose. We're trying to direct you down a specific route. So you might be thinking, Ms. Briscoe, there are several right angles in this scenario. Couldn't I be talking about like angle ABG over here? Couldn't I be talking about angle ABE? How do I know which right angle to talk about? In the given, it gives you information about angle 5 and angle 6. So let's focus in on the angle that has to do with angle 5 and angle 6. So I see angle EBC right here, and if those two lines are perpendicular, then I can say as my next step that angle EBC is a right angle, and that is the definition of perpendicular lines. Okay, that's what I'm allowed to say by the definition of perpendicular lines, that that's a right angle. Now that I know it's a right angle, now I can say the measure of angle EBC is 90. That is the definition of a right angle. That's what it means for it to be a right angle. Okay, so now I'm kind of stuck. Now I'm thinking, okay, I need to get my x's into my proof somehow, because my end goal is I'm trying to solve for x. And I am given information about angle 5 and angle 6. So I know some stuff about angle EBC, and I know stuff about angle 5 and angle 6. How can I connect angle 5, angle 6, and angle EBC? Oh my word! part plus part equals whole, I can use the angle addition postulate. So the measure of angle 5 plus the measure of angle 6 is equal to the whole enchilada, the measure of angle EBC. And that is the angle addition postulate. And so now I have information about angle 5, I have information about angle 6, and I have information about angle EBC. I can go plug all of that stuff in. Substitution. Okay. So now I can combine like terms, simplify, then I can subtract 5 from both sides. And slide all this stuff up. And then the grand finale is I can divide both sides by 5 to get x equals 17. Because I'm dividing on both sides, that is the division property. There we go. Voila.